the end. So we just do a delamination of every single layer, so we can recover of that stuff is a little bit critical right now, and they contain billions of euros when you 2006, 2008, and you see the amount of installed
third-party inspections as Sinovoltaics technique that makes microcracks visible. It cannot be replaced. So, hello everyone, and welcome to today's webinar on solar module lifecycle management, spanning degradation, reuse, and recycling. We've seen hundreds of gigawatts of solar added in the last couple of years worldwide, and this extraordinary growth is now colliding with an uncomfortable reality. New research from the University of New South Wales published this year shows that around 1 in 5 panels is degrading up to 1.5 times faster than average, with some lasting only half their anticipated lifespan. The waste consequences are significant. According to research published last year in PubMed, global PV panel waste is expected to reach 1.7 million tons by the early 2030s. Yet today, only around 10% of end-of-life panels are being recycled, with the majority dumped, burned, or buried. So today's experts from Solar Materials and myself will take you through exactly why this is happening and what the industry can do about it, from smarter procurement to reuse assessment to recycling innovation. So before I introduce the speakers, let me share some basic housekeeping rules. This webinar will last about 1 hour, and 3 expert presentations will be followed by a Q&A session. On the right-hand side of your screen, you can see the Q&A chat. Please use the chat box to share your questions at any point during the presentations, and I will address the questions at the end of the webinar to the respective speaker. This webinar is being recorded and will be uploaded on Sinovoltaics YouTube channel. If you don't want to miss the newest content updates on YouTube, don't forget to subscribe to our channel. And one final reminder, the presentations of the 3 speakers will be shared with the attendees after the webinar. So now, without further ado, let me introduce the first speaker. Franziska, feel free to jump on the stage. Franziska Roof, sales manager from Solar Materials. She brings a commercial and practical lens to the second life question. Franziska studied business management and is passionate about painting. Franziska, could we have you on the stage?
Hello, everyone.
Good to see you, Franziska. The next guest speaker, we have Dr. Janet Schmelzer. Dr. Janet, if you can jump on the stage, a warm welcome to you. Janet leads research and development at Solar Materials. Hello, Janet.
Hello from my side.
Where she heads the development of innovative recycling process across different panel types and oversees the continuous improvement of their recycling line. Janet also manages quality control for recycled materials, ensuring they meet the highest industry standards. Again, warm welcome. And last but not least, myself, Rasa Yakaitis, media manager at Sinovoltaics, communication professional with international experience in renewable energy, insurance, and tech. For 4 years, I lived in Belgium and came back to my hometown and homeland, Lithuania, 3 years ago. Currently at Sinovoltaics, I oversee international PR activities and also run this in a Sinovoltaics webinar program. Before I hand over the virtual microphone to you, Franziska, those who are joining Sinovoltaics webinar for the first time, I would like to briefly introduce what Sinovoltaics is and does. So Sinovoltaics is a Dutch-German company providing technical compliance and quality assurance for battery energy storage systems and PV worldwide. We offer inspections, factory audits, ESG reporting, and traceability audits for utility scale developers and investors. And with over 15 years of experience, we have already audited more than 350 PV and BESS factories globally, covering all major components such as modules, inverters, transformers, cables, etc. With boots on the ground in Asia and around the globe, we are a trusted partner for your highest quality renewable energy projects. So now I invite you, Franziska, to take the virtual microphone and present your topic.
Thank you very much. Hello, everyone. I'm delighted that you are here and yet that I can share some information with you about Second Life. Even though I can't see you, but I'm looking forward to seeing you. My name is Franziska Ruff, and today I'm standing here for my colleague Luisa Schulze, who is responsible for the Better Soul brand and consequently the Second Life division at Solar Materials. The energy transition is fully in swing, and the expansions of the solar energy is growing exponentially. We all need this trend to create a future-proof world. But what happened with the solar panels at the end of their lifespan, or once the subsidy has expired? Solar Materials offers the solution here and closes the loop. Decommissioned modules are sent to us in Magdeburg, where we inspect the solar modules that have been disposed of by commercial operators. This allows us to separate the functional solar modules from the defective ones. Whilst the defective solar modules are sent for recycling, we resell the functional ones at the Second Life modules via our own online shop. You might be surprised to learn that one in two solar panels is disposed of prematurely. According to studies by Irina and Circularity, half of the solar panels that are disposed of are actually still in working order and can be reused following an inspection or minor repaints. To give you a better idea, this means that by 2025, the total energy needs of all households in Braunschweig could be recovered by the solar panels that we are disposed of too early last year. Sorry. Premature disposal often results in the loss of critical and finite raw materials. Valuable energy is also lost. In 2030 alone, this energy loss will be equivalent to the output of 5 gas-fired power stations. At Better Soul, we aim to save the still functional solar panels and the renewable energy they generate from premature disposal, thereby combining two essential drivers to the future: the circular economy and the renewable energy. On this slide, you can see our business model. We source used modules from various commercial suppliers, store them at the site in Magdeburg, and then test them using our in-house testing facility. All modules that pass the test are then listed in our online shop and sold, for example, as balcony solar power systems. In principle, all modules are suitable for testing, provided there are no known faults, such as glass breakage or defects on the back sheets. Any modules are not suitable for reuse are recycled by Solar Materials, thereby recovering all valuable raw materials. My colleague Janet will tell you more about this in a moment. We work with various recycling companies, solar farm operators, and resellers to purchase used solar modules. The reason these companies work with us is that for the first time, they receive a refund for their still functional solar modules and thus avoid the recycling fee for all such modules. We collaborate with recyclers, IPPs, manufacturers, and resellers of new modules. Recyclers such as Weiling in Germany are delighted to be able to generate revenue from the consider to the waste. The reason these companies work with us is that for the first time they receive a refund for the solar panels that are still in working order, thereby avoiding the recycling fee for all such panels. Perhaps we will soon be able to turn the waste into a profit to positive return as well. In the diagram, we assume that 15,000 solar modules are being proceeded. In the purple scenario, you see 100% recycling of all modules at the cost of €2 per module. The total costs are approximately €30,000. In the blue scenario, you see the assessment for reuse can, with an 80% second life capability, and 20% of the 15,000 modules are recycled. The repayment is 1 cent per watt peak. To determine whether modules are suitable for second life use or recycling, they must be tested. We carry out these tests on the modules. At our site in Magdeburg, our modules undergo a multi-stage testing process. The testing process begins with a visual inspection to exclude modules with visible defects, such as broken glass or cracked backsheet films, from reuse. Performance measurements allows the current output of the modules to be measured and their degradation calculated. Electroluminescence measurement reveals cell defects such as hotspots or microcracks. Finally, testing for electrical safety ensures that electrical faults in the modules are ruled out. Once inspected, our second life modules are sold via our online shop to B2B and B2C customers. Our modules are 30% cheaper than new modules offering the same performance. They are sold under the Better Sol brand, which is dedicated to selling inspected high-quality second life modules. By reusing solar modules, we can offer a comprehensive end-of-life management service for used solar modules, comprising both recycling and reuse. Through reuse, we close the loop and act in accordance with the waste hierarchy. Critical and finite resources, such as silicon and silver in the solar modules, can't those be reused and are not lost. Reuse can save more than 160 kilograms of CO2 equivalents per module. I hope these benefits impress you as much as they have impressed me. We look forward to hearing from you. Please feel free to get in touch with any questions. If there's anything we can answer straight away, we will pass it on to Luisa Schulze and get back to you. And with that, I would like to hand over to my dear colleague Janet. She will give you a more in-depth look in the recycling process at industry leader Solar Materials. Thank you.
Thank you, Franziska. We have a lot of questions incoming your way, so it will be a busy Q&A session. Janet, we invite you on the stage, and I hand over the virtual microphone to you.
Okay, thank you very much, and as well thank you, Franziska, for telling something about the second life of the PV modules. But when second life doesn't work, it comes to recycling, which is pretty good. Where is my... here. Okay, sorry. So I want to introduce Solar Materials a little bit. So what are we doing? So we could say we transform solar waste into strategic raw materials. So with the recycling of silver and silicon itself. So something about the company Solar Material was founded in 2021. It is founded out of a university research project, and at the end the two research workers are founding that company in Braunschweig. Now it is moved to Magdeburg because we have here a little bit more space for all the modules. So we grew very fast in the last years. So we are now over 60 employees. And our capacity for the last year was 7,000 tons of PV models we recycled. So, and we still grow. So this is just the beginning of the solar materials recycling stories. So yes, what kind of material we recycle? So of course, PV models. And you see here, I think everyone is familiar with the typical layers of the module. And the interesting fact is just right now that around about 95% of the installed modules are at the moment crystalline silicon solar modules. And how are they recycled, or how were they recycled up to now? Most of the panels were recycled by shredding and sorting. And this is pretty much okay, because with shredding and sorting, and afterwards having the glass as well as the aluminium fraction, you have recycled 80% of the module, which is directed by law, so everything is fine. But what I want to address during that presentation is that one can do it better. So here you see a nice graphic of how many modules we will receive until 2030. So you see that there's an annual growth of the installed waste volume. So, and you see it grows really fast within the next years. So, and this means we have millions of tons of installed PV modules, and they contain billions of euros when you think of the materials which are inside of the PV modules. So for us as a recycler, we live in the past, so to say. Yes, we always live 10 to 15 years behind the production. This means right now it is a medium thing that we receive the modules after 10 years of being in the field. So this is what we get now. So we are now here at 2006, 2008, and you see the amount of installed PV modules which come back now to us is high, but you see that within the next years it will be much higher. So, and this is the point where we are now, that we need recycling capacities to get back all the critical raw materials which are inside of the modules. So what kind of modules do we receive at our facility? We receive production error modules, damaged modules by hail, by storm, by all the things, dirty modules which don't have a good fit anymore, and as well the end of life modules, here with a lifespan of 25 to 30 years, but most of the time, due to the repowering of the parks, they come back earlier at 15 years. They are at the end of their life. So this is what we receive from big solar parks, which are most in a good condition. And we also receive modules out of from the local points. This is a little bit, I don't know how to say. There are many different modules. This is not so easy for us. This is easy when you shred and sort it at the end, but we do it a little bit better. So I will come to this point now. The problem is, so when everyone gets back these modules and want to recycle them, you get back the aluminium frame, which is pretty easy, so to say, and you can recover the glass, which is also well understood right now, but silicon and silver is most of the time lost. So The recovery rate is nearly 0 for silver and silicon, but around 10% of the annual silver production is used in the solar industry. So you can imagine that it's a lot of material which is gone at the end of the day. So that was why we asked us different questions. So how can we efficiently recover the silver? How can we increase the purity of the recovered silicon? And what can we do with the tons of recovered plastic? So how can we do it safely? What kind of models do we expect within the next years? And how can we establish the good capacities for recycling? So first question is, how can we efficiently recover silver? So the fundamental thing when you want to recover silver is, of course, you can't shred and sort it at the end. So you know that around about just 1 or a little bit less than 1% of the weight mass of the module is silver. So when you think of a big shredder where all the stuff is put in, so how can you get back at 1%? It really doesn't work. So the fundamental thing, and this is what Solar Material did, we did a kind of reverse production. So we delaminate every single layer to get access to every material in a pretty good quality. So our process works as the following. So we start with deframing the module, and then we get rid of the glass, and then the biggest challenge starts. So we have the encapsulated wafer. So on the wafer, the silver fingers are printed on, as well the bus bars, and all the stuff is pretty much interesting for us because there the silver is located. So the thing is, you have to get access to the surface of the wafer. So, and for that reason, you have to get rid of the encapsulant. So this is not so easy, as I already told, and there are different ways to do that. You can use a thermal way. You can also use a chemical way, or you can use a mechanical way. But yes, at every time, no advantage without disadvantage. And so here is a little overview of some advantages and some disadvantages of different techniques. So you see, some of the points like recovery, all high value materials are ticked from with a green tick. So for some of the points, but you see a lot of red crosses. So this means the processes work, but not pretty well. So and for that point, Solar Materials try to get a single and completely new way to recycle the PV models. We don't use any chemicals at the moment. We only work in a thermomechanical way. So this means when you don't use any chemicals or you don't have pyrolysis or something else, you can really good scale it up. You have pretty low investment costs. Yes, you have a relatively high throughput. And the best thing is, so as I told before, that we don't shred and sort at the end. So we just do a delamination of every single layer. So we can recover all high value materials. We can also recover plastic materials, and it's all the time profitable without a recycling fee. So this is a pretty big advantage. And here coming back to the silver, which is really, the economical driver for our recycling model. So you see 0.1% of silver within the module, but around about 50% of the value. So it is pretty much worse to recover the silver because at the end, so you will be profitable with the silver as well as aluminum frame, as well as the glass, when you're able to recover pretty much clear material streams. So a showcase here is some elemental silver nuggets, which come out of the PV modules, so to say. So I can't really tell you something about the process because this is our IP, of course. I think you understand that. But we put in the PV laminates, we have our special process, and at the end, you see we have that elemental silver out of the modules. You can say that, yes, there are around about 10 grams at the moment per module silver, and we are able to recover, yes, 8 to 9 grams of it. So the process works pretty well. I see some questions here rising next to me, but I will go on and we have it later in the Q&A. So, okay, how can we efficiently recover the silver? With our own process, we can do it pretty efficiently and in a pretty good quality. So next question is, how can we increase the purity of the recovered silicon? This is a bigger issue, I think, currently at the moment. Yes, status quo of the recovered silicon is really, yes, good, but not really good. So we have a silicon metal fraction with a purity of higher than 95%, around about 96%, I would say. We also have impurities like silver, like aluminium and tin, as well as lead and other metals which are in the module. Yes, the usage of that stuff is a little bit critical right now. So yes, due to the high impurities, it is even not usable right now as technical silicon. You can only use it in non-ferrous alloys currently. The target is, we want to upgrade it to solar grade, which is 6N. I'm not pretty sure if it is necessary. So currently there's really no need for silicon here in Germany, especially. Nobody really wants to buy it. So it is as well pretty cheap currently. So I don't know if there is a big need to purify it in that 6N grade. Maybe 4N grade would be also fine. But this is a big issue currently, and nobody is really aware of how the story is ending. So nobody knows what kind of quality we want to achieve at the end. So we can say that we are able to recycle the silicon in the more or less quality I told you here, which around about 96% purity, but the rest is still open right now. So something about the improvement of the quality. Okay, what can we improve as a recycler? So we could, improve our recycling process. We could delaminate maybe the silver a little bit better because we have still rests on the wafer at the end. So this would something that work. And also you could get better separate all the impurities before you shred the silicon. As well, you could prevent from external contamination, like abrasion from the machines or something like that. These are tasks for us as a recycler. Yes, then something would improve itself, or would solve itself, because within the next year we will receive PV modules with different ingredients, so to say. So like the PERC cells, like the TOPCon cells. So then the story is really another one. So, but most likely at the end, so with a real recycling process, you can't achieve a really, really pure silicon at the end. So most likely we need to involve some wet chemical processes. But I don't think that this is a task for the recyclers at the moment. So, but without any chemical treatment, you won't get a really, really pure silicon at the end. So this is really a challenge for all of us. So for the recyclers, for the chemical industry, and everyone who feels addressed. So, and then another issue I want to address here, because we are faced with it every day. So what can we do with the recovered plastic? So we can recover plastic in a high quality. As I said, we delaminate all the layers of the PV module. And so at the end, we also delaminate the EVA encapsulant as well as the backsheet. But currently, there is no market for the plastic fraction. So we have some research projects where people try to reuse it in different applications, but currently most of the stuff is going to incineration and generate energy. But this is really non-profitable at the moment because we sometimes have to pay for it. So this is a question I address also to you as the auditorium. If you have any idea what to do with the recovered plastic, please feel free to reach out and give me some hints. Yes, because plastic, yes, offers some things that are not so good. All the time, we always faced with yes, unknown variations in the material composition because yes, 20 years ago, nobody thought about the recycling process at the end. So there are no bits of material or something like that. So yes, everyone used an EVA layer, but yes, what kind of additives, what kind of stabilizers, and all those things are pretty unknown. So then due to their lifespan, they come to us with different physical and chemical properties. So some of them, I don't know, were installed maybe as an extreme example in Africa, and some of them in Germany where not so much sun is shining. So this directly affects to the chemical properties of the plastic materials. As well, we have some contaminations with glass, metals, and silicon. And the big problem is the fluor content in the backsheets, especially. And of course, yes, transport costs are also an issue because we have pretty low densities. So if you have any idea, please feel free to reach out. So another point is, how can we do this safely, this recycling of the PV modules? So we learned a lot during the last years. So how we handle all the hazardous materials and all the stuff. And yeah, what kinds of, or what points I want to address today to do it or to get it more safely is, of course, compliance with standards. So standards are given right now, but I think there's a lot of space to, yes, to make them more or make them better. As well, I think it is pretty much good if you have an automated dismantling. So if you use robotics to minimize the manual handling as well as the risk of accident. And a big point is dust and fume extraction. So when you imagine that tons of modules are shredded, and you can imagine that this is a really, really dirty business. So in our process, the delamination is a little bit better. So, but we are also faced with the hazardous materials within the module. So this is lead, which is pretty not good for the workers in the facilities, which is tin, also not fine powder materials, so of silicon. You can imagine that this is pretty much hazardous for all the persons who are dealing with it. And when you imagine all of the capacities we are working with, this is not one module per day or two. These are tons of modules during the year. So we have to find something which makes the recycling process much cleaner as it is today. So training and monitoring is also quite important. So which modules do we expect in the coming years? So I think you are all familiar with the new types of models which will arrive, like perovskite cells as well as thin layer modules. So yes, new technologies emerged, and then we also have to handle it during the recycling process. This means when you think of the crystalline silicon modules, they are pretty easy. So they just have the wafer and the silver, and of course lead and something like that is also in it. But then you have the glass and the encapsulant. But you see here, you are faced with, especially with the thin layer modules, with cadmium, with tellure, with all the stuff. And so recycling will become more hazardous for that kind of materials as well. You can't easily recycle that small amount of contaminants or of ingredients which are in the module. So this is also, yes, something which gives us strong headwind currently in our R&D development. So then you have the regulatory things which, yes, should impose stricter producer responsibilities. They should provide the bill of materials for the recyclers, because the business is pretty much easier when you know what you are dealing with. So then we could work a little bit more in our safety conditions. So we have the hazardous materials, as I already mentioned, indium, gallium. So then we need special approaches, because you can't bring them in the environment. So this is a lot of work for all of us. So now we have understood the recycling of the crystalline silicon modules, but with the next generations, we will be busy for the next years. And something about the recycling capacities. We are thinking about how can we establish good recycling capabilities. So yes, everything is more or less installed, decentralized. So maybe it is easier to install some regional plans to minimize the logistic costs as well as the CO2 emissions. So logistic costs are at the moment pretty or big pain, so to say. So we all know that the costs for the fuel is pretty high. So this is a big pain currently for us, especially when we receive the modules from far away. So it is, I think, for the future, pretty smart to have a decentralized network as well. Yes, some integration collecting systems are also possible. That you have an efficient material flow as well. The policy should be involved. And yes, some industrial clustering would also be fine, because then you also don't have that logistic cost at the end of the recycling. When you bring or when you sell the materials, maybe you should locate your recycling facility in the vicinity of some glass processors or something like that, refiners and all the stuff. So yes, this could be pretty well when everyone is thinking of how can we do it a little bit smarter, how can we save logistic costs and all this stuff. So there is a lot of things to do within the next year. So when we scale all the recycling plans and we have that expected big decommissioning wave. So a little sneak peek here from our facility. So this is a view to one of our recycling lines, so which is fully automated. And we will expand within that year to the recycling amount of 21,000 tons. By the end of the year, this means we scale up to 3 fully automated operation lines. And here, our materials we sell after the recycling process, as I told before, is the aluminium frame, the copper cables, the glass, currently in a flat glass quality, so pretty good glass, the plastics, where we don't know what to do with currently, the silicon. I addressed also a little bit the quality of the silicon, which is a point to work on, and the silver, which is then going to refinery and ends up at the elemental silver. So with that point, I'm at the end of my presentation, and thank you for listening.
Thank you, Janet. Yeah, really interesting to listen. And I think also that signifies the number of questions we received. We have more than 40 questions. So before we delve into Q&A, I'll briefly present what causes the degradation of PV modules and how you can prevent that. My part will be really quick. So yeah, thank you, Janet, and I will see you in a bit.
Okay.
So as we now know how we can reuse the modules that are still operating, and what can we recycle from the modules, or what, or we don't know what to do with some of the materials recycled or recovered from the modules, like plastic. Let me just quickly present on what are the key drivers of PV module degradation and how can you prevent this before commissioning. So in the intro of this webinar, I already cited the recent University of New South Wales study that analyzed nearly 11,000 of PV modules globally and found that 1 in 5 modules degrades at least 1.5 times faster than expected, and roughly 1 in 12 degrades twice as fast. So for some systems, useful life shrinks to just 11 years, with 45% of output lost by year 25. The researchers identified 3 causes: cascading compound failures, infant mortality from manufacturing defects missed in quality control, and latent minor flaws that seemed harmless at first until they don't. And critically, climate is not a driver. These failures happen everywhere. So what are those flaws? Let's look at some of the most impactful that we see in our work. So the microcracks are the most pervasive hidden defects in the industry. According to National Renewable Energy Laboratory in the US research, 84% of PV modules contain at least one cell crack, and most are invisible to the naked eye. Many originate during the manufacturing at the cut edge, then grow into dendritic cracks during transportation and installation. Under thermal cycling and mechanical load in the field, they propagate, blocking cell areas, triggering hotspots, and opening pathways for moisture ingress. Then the next pain point is junction box failures. Once moisture and heat reach the junction box, incorrectly soldered contacts, already more common in newer module designs with shorter cross-connect ribbons, fail. Bypass diodes disconnect, hotspots form, and we've seen a case on a 12 megawatt rooftop site in Taiwan. 700 out of 3,500 modules developed junction box hotspots from a single soldering defect. The manufacturer replaced the modules, but did not cover the labor costs to diagnose and remove them. The third quality flaw is encapsulant degradation. Poor encapsulant quality or incorrect lamination is the flaw that activates everything else. When EVA degrades, it produces acetic acid, which corrodes cell grid lines and bus bars, promotes potential induced degradation, and accelerates delamination. The International Energy Agency for the Voltaic Power System Program Task 13 for Reliability and Performance of PV published a report in February last year that states plainly, the current IES 61215 tests are not designed to detect the long-term stability of polymer materials. And this is a known gap in the certification system. There are way more defects that, if undetected, can lead to faster module degradation, and many of these defects don't develop in the field. They ship with the modules. But the good news is that catching them before they ship is far cheaper than catching them after. A robust procurement QA quality assurance approach requires 4 layers. So factory audit, check your supplier, their financial health, ESG policies, confirm that certified line is what actually producing, it's what's actually producing your order, not an OEM or subcontracted facility. During production monitoring, catch batch level material or process deviations before they become your problem, and third-party inspections as Sinovoltaics can help you with that. Then pre-shipment EL inspection, electroluminescence imaging is the only technique that makes microcracks visible. It cannot be replaced by visual inspection. By using Sinovoltaics' proprietary AI-based tool, Selma, we can analyze 100% modules from your order. Then another important point is factory acceptance test, a formal documented sign-off at the factory gate, confirming the full consignment meets contractual specifications, including power class, visual quality, and EL results, before ownership transfers and models are shipped. The last quality control measure is site acceptance test, repeat verification once modules arrive on site, before commissioning, checking for any damage sustained during transit, and confirming that what was tested at the factory is what has actually been delivered, as it is your last line of defense before installation begins. Here you can see some single cracks spotted during EL imaging tests that we analyze with our proprietary tool, Selma, and we very often share about these findings on our LinkedIn channel. So the conclusion, the modules you procure today determine whether your assets can be repaired, reused, or must be recycled in 10 or 15 years, but you need to move your quality assurance upstream, not downstream. So now I invite the two guest speakers from Solar Materials, Janet, Francisca, back on the stage. We have more than 40 questions in the chat box, I believe. We have a good of 15 minutes for the Q&A session. So let's wait for the guest speakers to come on the stage and we can continue. Yeah, I see Francisca coming up. Again, to repeat a message from Francisca, since today she's on behalf of her colleague Luisa, some questions we might not be able to answer, and we won't be able to answer all of the questions out of more than 40. We'll do our best. With those that we cannot answer live, we will try to answer via email after the webinar. So, as you started the presentation, Francisca, you shared some statistics suggesting that every second disposed solar panel still works. Was that statistics from Germany or broader Europe?
It's from Germany.
Okay, thank you, and thank you for addressing this question to Mona. Then, again, question to you, Francisca, if you're able to answer. What is your operational experience regarding the viability of solar panels for reuse? Are actually 50% of panels still viable for reuse? What about their commercial viability of these panels?
One moment, please. This the solar panels degrade very slowly at the rate of 0.5% per year. This means that after 10 years, the panels have lost just 5% of their output. Our tests show that in some cases the panels degrade even more slowly than the manufacturer's guarantees. This ensures the electricity generation remains a viable option. So we think we can use more than 90% of the modules after testing. Between 80 and 99%.
Okay, and that is after how many years of being on the field? Do you have like an average statistic?
Mostly after 10 years.
Okay, thank you. And let's just mix some questions so that we have a question to Francisca now. And this is maybe just a rhetorical question, but Why do you consider silicon to be a critical and limited raw material? It is abundant and cheap to source as far as I know, only very energy intensive to produce. Hence, that is the main aspect in my view to reduce virgin material use. That is a question from Alexander.
Yes, I think it is addressed to me, or?
That's right.
Yeah, okay, good. Yes, this is the point. So nobody wants to have the silicon right now because it's pretty cheap, but we have a lot of it. So, and it's also on the list of critical raw materials within the European countries. So I'm not sure how to behave. So this is pretty my question. So yes, we can recycle it in that grade I told you, but we really don't know what to do. Currently, the most important thing in the silicon fraction is the rest of the silver, to be honest. So this is quite, I don't know, I think a big issue because in Germany last year, at the end of last year, our last silicon production facility was closed. So there is really no need in Germany currently. Nobody buys it. So we have some contacts to other facilities, but yes, a pretty good question. So it's cheap. Nobody wants to have it. But what I read about the silicon is that, yes, you told the refining and to get back pure silicon is pretty cost intensive. So I read in many scientific papers that some addresses a remanufacturing of the wafers direct out of the PV modules. So because you save a lot of energy because you have that fine product and you could reuse it, but I think it's pretty hard to recycle an intact wafer out of the PV module. So this is something I really try sometimes when I have time for that nice topic, because I also think it is worth to do it because we have that lot of material. But yes, a question, I don't know, sorry. I can't give you the right answer, so.
Yeah, I guess there's no right or wrong answer. It's just a perspective. Thank you, Janet. Another question from Inaki. How do you define a working panel can be reused or resold or goes directly to recycling? Where is the limit? Whoever can answer, maybe you, Franziska, or you, Janet.
Yeah, I think so. I'm not so familiar with the second life stuff. So, but as far as I know, so it is, of course, first intact glass layer, the intact frame and all the stuff. So it is some visible stuff. And at the end, then it goes to the test machine. And if it reaches a defined output, so it then goes to the second life. And if not, so it comes to us for recycling. But I can't tell you really the threshold.
Okay.
So this is something I think Luisa could answer better than, so you should address this per mail.
Yeah, then we'll do that via mail. Thank you, Janet. What about the warranties? Because we've had a couple of questions about the warranties, product and performance of the second life modules.
The warranty is about 2 years. It's the normal standard warranty we have to give. So it's 2 years.
Okay, but just let me jump in. We work on a certificate for that kind of modules. So to give...
Okay. Can you elaborate maybe on that certificate, Janet?
Sorry, I didn't get you.
Maybe you can elaborate on that certificate, like what does it truly mean?
Yeah, this is our latest research project currently. So we want to establish a certificate and we're working with different institutes to get a list of things so we can address and then we will test it. So it's just in the beginning phase.
Do you know, like, what's the timeline? You know, do you expect to have it still this year or in 2027 rather?
Yeah, I think 2 years.
Okay, thank you. All right. Again, about the guarantees, and I'm not sure if you can specify that. So over the time, the performance of the modules decreases. What guarantees do you offer to buyers interested in these second-hand modules? In particular, for IPPs that may be interested, a performance guarantee is essential to the viability of their business model. Or is it still the warranty like for 2 years? So far, until this certification is established.
I think so, but I think we have to ask Luisa for the final answer. But I think it's also 2 years. Yeah.
All right. A question from Mona again. Are the source of modules primarily utility scale solar farms, or does it also include commercial, residential modules that you get?
For recycling, yes, in the lucky case, it is really from solar farms, because you have lots of modules from the same type. This is pretty much easier for us as you think of our delamination technique. But we also receive from residentials too, yes. They are most of the time not in a good condition, unfortunately, because, yes, collection points don't handle it pretty good. I think they should be aware of what kind of material they are dealing with. So a lot of value is in it, and they really treat it like waste, of course, yes. This is a little bit something in my, what we should have in mind right now, that we treat the electronic waste a little bit better, because there are lots of values in it.
Yeah, that's very true. Again, a question to you, Janet, from Victor. In your presentation, you mentioned that you improved the recovery of silver and silicon. Are you able to keep the recovery rate of other materials?
Yes, 15% is the aluminium frame, because it's just the whole aluminium. And as well, we are able to get back the whole glass. I can't tell you in a percentage, to be honest. So, but we don't have any residual glass on the module, so it's complete glass we recover. Yes, and then plastic fraction. I don't know. This really depends on the process we are scaling up right now, so I can't give you precise numbers. But for silicon and silver, I already told. So I think the most important things we recycle now is glass, aluminium, and the silver, which are the value driver.
Great, thank you. A financial question from Kara, Kara. In determining recycling profitability, do you include extended producer responsibility funding for recycling, or is it completely unsubsidized?
I'm really not sure what you mean, because it goes more in the financial direction, and I'm more dealing with the R&D stuff. So
okay, then maybe Clara can
I can back
reach
to
out.
you. Can come back to you with that question. Yeah, I'm sorry.
Yeah, not to worry. Thank you. A question from Stanislav, and again a financial question, so we might not be able to answer
I can answer
one.
this. This is interesting, because I'm more aware of that topic.
Okay, let's go for it then.
Yes, this would be currently a big problem, because the price for the aluminium is pretty high currently. So, and if we don't have the aluminium frame, there would be a loss of revenue, of course. Yes. So, but nevertheless, it will come to us. So we will have to deal with it. So currently, it is pretty good to have these old modules with the nice aluminium frames and the big amount of silver. So, but within the next year, we would completely change. So, but our processes will be better. So I think over time we can handle this topic. But yes, of course, without aluminium frame, a big amount of good or pricey second raw material is getting lost, yes.
And since we are running out of time and still plenty of questions to address, I'm just going to read a comment from Sunil about the plastic issue that you're facing. So Sunil is suggesting that the recovered plastics can be used in PPCP lead-acid battery containers, which generally have 20% of recycled plastic granules. So maybe this is an idea, and you can explore with Sunil the idea together later on. But I thank you both, and thank you the audience for so many questions. I think it symbolizes that the topic is really important and still worthwhile exploring. In case you have, a directed questions, because there were so many questions, like a scientific questions to you, Janet. So feel free to reach out directly. I think that what we've heard is today that is the degradation of PV modules is happening faster than predicted. The root causes are different, but the good thing is that we are able to recover at least some of the materials and to reuse some of the modules. But the most importantly, I think that the robust quality assurance program before you purchase your PV modules can extend the module lifespan. So again, really thank you, Dr. Janet Schmetzel and Franziska Roof from Solar Materials for such practical and evidence-based insights today. Recording will be shared with the attendees of this webinar, and I will soon welcome you in the next Sinovoltaics webinars. So thank you.
Okay, thank you from my side as well.
Thank you very much.
Bye-bye.
Bye.
Visit sinovoltaics.com to learn more.